Solving quadratic equations by graphing. Quadratic equations can be in different forms. For example, this quadratic equation, if you wanted to solve something like this, you would need to factor the equation and find the roots. The root of an equation is also known as the zeros. So when you set the equation equal to 0, that's known as the zeros. If you set the equation equal to 0, it's also known as the roots. Another way to say it is the x-intercepts, or finally you can say it's the solutions. Either way, what you're trying to find out is what values of x can I plug into this side, the left side, and what will make it equal the right side. In this case is 0. So we need to be able to find quadratics, solve quadratic equations by graphing, by looking at the graphs and determine does it equal. So we have a couple of examples. Let's start with the first one. The population of SimCity is modeled by the function p at t is equal to 0.5 times t plus 20 squared plus 100, where p at t is the population in thousands and t is the time in years since 2000. So again, p at t is the population in thousands. So we're asked now, what was the population in 2000? Well, we have an equation, folks, and we have an equation which is important, okay? This equation, and we need to know what the population was in 2000. So it's going to help. We need this information here. The other pieces that are important, which I'll highlight in pink, is what p at t is in terms of thousands and what t is in terms of since the year 2000. So the yellow parts are the important pieces, the formula and what we're being asked. The pink are the units and the variables that are introduced there. So we're asked, what was the population in 2000? What does that mean? Well, that means that now we need to look at how many years is it from the year 2000 when we want the year 2000? So how many years is it between these two values? Well, hopefully you're saying that it's 0. That's right, 0. We sub t equals 0 into the equation, so p at 0. Now remember, p at 0 is like y equals. That means when we're looking at this, we want to say y equals the equation. The equation is 0.5 times 0 plus 20 squared plus 100. What this means is that we're actually saying at what value is it when it's 2000. P at 0 means what is the population in 2000. So we have to circle that because we do not separate that ever. And what we're doing is calculating the other side. And we find out the answer is 300. What does that mean? Well, it's 300 what? It's not just 300 people in the population, but 300, that's right, thousands. Because that is what it says in the question, that p at t is the population in thousands. So we sub 0 in for t. We found out the answer was 300, and we now write the therefore. The therefore, the population of SimCity is 300,000 in the year 2000. All right, folks, moving on. Part B, what is the population in 1990? Well, how many years is it from 2000 to get to the year 1990? Hopefully you're thinking that t is going to be -10. That's right, -10, because 1990 is 10 years before the year 2000. So, p at -10, remember that's a y equals. Do not separate these two, folks. They stay together, so I'm circling them to remind you they stay together. 0.5 times -10 plus 20 squared plus 100, we plug it in and we get 150. So 10 years prior, the population in 1990 was 150,000 in SimCity. Okay, moving forwards. Part C. When is the population expected to reach 1,050,000? Now this one's a little tougher because this time we have to say P at T is equal to 1,050,000. But wait a minute. 1,050,000, we have to take off the thousands part of it. So that's actually 1,050. 1,050 is equal to 0.5 t plus 20 squared plus 100. How do we solve this? Well, we do it step by step, folks. We take the 1,050 and we move the plus 100 to the other side, and it becomes 1,050 minus 100 equals 0.5 times t plus 20 all squared. 1,050 minus 100 is 950, is equal to 0.5 t plus 20 all squared. What do we do now? Well, looking here, we want to move this one over. So 950 divided by 0.5 is going to equal, that's right, 1,900 is equal to t plus 20 squared. Now we have to get rid of the square, so we have to take the square root. Now when we take the square root, we have to consider two cases, because there are two possible cases of numbers that could have been squared here. One could have been negative and one could have been positive. So we have to include both cases. The square root of 1,900 is what we definitely need, is equal to t plus 20. Now we're taking the plus 20 and moving that over, folks, and we get negative 20. So now, how do I get these numbers here? Let's look at how to understand this. The square root of 1,900 is plus or minus 43.5889. But what I want you to do, because again, some of you might be considering moving up in the math, we have to keep these numbers as exact as possible. So the idea is we can't touch our calculator until the very last moment. So no calculator, folks, and we need to keep working with the exact values. So plus or minus the square root of 1,900, we leave it the way it is. So t equals negative 20 plus or minus the square root of 1,900. So now that we've moved everything over and t is by itself, we can now touch our calculator. T is equal to, now we're going to add negative 20 plus the root of 1,900, and then we're also going to subtract. Okay, but first, so we're also going to subtract, folks. So, first thing, take negative 20 plus the square root of 1,900, and folks, you should have gotten 23.5890. Then, I would have taken negative 20 and minus the square root of 1,900, and that would have given us negative 63.5890. Again, type the plus in this question, you get this. Minus in this question, you get this. Now we have to figure out what year it is, because remember, this is how many years since 2000. So we have 23.5889. Just a reminder of the rounding. So a lot of people have some difficulty with the rounding, so we're just going to give you a little reminder. So these are the numbers you get in a calculator, and you automatically round to 4 decimal places unless it otherwise says. So we go to the 5th number and we see that's an 8. 8 means the next number moves up, so the 9 becomes a 10. All right, the 9 becomes a 10. When I add a 10, that 8 now will become a 9. So that's how it became 5890. So it's really important that you understand how to calculate these values. So it's 58 and then a 0. So you add 89. 89 becomes 90. So in 2024 and in 1936, the population reached 1,050,000. So in 1936 is because it's negative 64 years since 2000, and the other one, 2024, is it's 24 years after the year 2000. Okay, next question. So we have a question here. It says find the zeros, okay? All you're doing is finding the zeros. Now, we can factor this parabola, or we can, factor this equation, or we can look on the parabola and find the zeros right here and here. So let's practice First, by looking at the parabola, so we can see that here it looks like it's going to be -5 based on the scale, and +7 based on this scale. Let's check by factoring. So we need to factor this expression. So the product is -35 and the sum is -2. We know that x squared has to be to x and x, and we want to get -7 and +5. -7 and +5. And look, folks, when we look at the root, this root is going to be, when we set it equal to 0, because remember a root means the zeros, we have x equals 7, and that was this number right here, and x equals -5, and that is this number right here. So interesting, the graph and the equation will give us the same answer. Let's hope it does. Anyways, moving on. Let's do the next one. Let's factor this one. All right, so pulling out the negative, the x squared must be positive, folks, in order for us to factor. So we pull out a negative. We set it equal to 0. In fact, we probably could have even moved everything over if we set it to 0 first. But the idea is we need to find the factors. So what two numbers multiply to give you -4 and add to give you -3? That's right, -4 and +1. -4 and +1 are our factors. What are our roots? Well, x equals -1 and x equals 4. So let's check on here. We can see that it's -1 here and 4 over here. So -1 and 4 are our values that we're looking for. Okay, and moving on. Let's see if there are any other issues we need to deal with. Nope, that's it. Okay, so folks, we've now solved all of these. These are the answers, and that's the end of the video, folks. Have a numerical day.